Assalamualaikum warahmatullahi wabarakatuh. My name is Daniel Aiman bin Nozari. My student ID is 2013928831. My program is UR65230008 and my lecturer is Encik Amin Nazrin bin Abdul Rahim. So today, I'm going to discuss about the assignment that have been given to me. So for question 1, based on figure 1, determine the complete sum and intermediate carries C out by analyzing the operation of the circuit in figure 1. Based on figure 1, this circuit have 3 binary input and 2 binary output. The binary input contain A, B and C in, while the binary output contains C out and sum. For this question, we have to find output for sum and C out. When the input given, A equal to 111 and B equal to 101. C in is combined with ground and equal to 0. A equal to 111 is A0, A1 and A2. For B equal to 101, equal to B0, B1 and B2. So 1 plus 1 equal to 10. 1 will be C out and 0 will be sum. So for question 2, write the sum of product for 2 Roman. 1 Roman, write the sum of product SOP for sum and Cout of full adder. SOP condition is when the output is equal to 0, the expression of Boolean is A bar. And when the output is equal to 1, the expression of Boolean is A. So this is the answer for question 2 1 Roman. SOP for output, sum and Cout. SOP is where the output equal to 1. Then we assume the input 0 is A bar and for input 1 is A. In this question, I need to create Boolean expression based on the truth table. Based on expression 1 Roman, I need to create a K-map for output sum and carry out. K-map used to make a simplified expression. After the simplified expression is done, I have to create logic circuit based on expression that have been simplified using K-map. This is the circuit connection for 2 Roman. So for question 3, sketch the 4-bit parallel adder and determine the sum and output carry for the addition of the following two 4-bit numbers if the input carry is 0. I need to find the output sum and carry out if A equal to 1010 while B is 1001 and carry out input is 0. Then I need to set up the C in as ground, which means equal to 0. The sum of input is 001 while the carry out is 1. So for question 4, for 1 Roman, design a 4 to 1 multiplexer by showing the truth table and Boolean expression. In 4 to 1 multiplexer block diagram, there are 4 input, 2 selector and 1 output. Based on theory, the output for multiplexer will refer to the data input that had been selected by selector. For example, when selector 1 and selector 2 is equal to 0, the selector will select the first data input. So, from 4 to 1 multiplexer, I have made truth table and the Boolean expression. So, for the question 4 to Roman, I have to draw a block diagram for a 8-to-1 multiplexer using 4-to-1 multiplexer. For design 8-to-1 multiplexer, I use two block diagram of 4-to-1 multiplexer, and the output from this two block diagram will be combined and connect to OR gate. The block diagram of 8-to-1 multiplexer consists 8 data input, 3 selected, and 1 output. So for question 5, I have to design the 2-bit comparator. Figure 3 shows a block diagram for a 2-bit comparator which compares two number x and y and produces two outputs x greater and equal. The 2-bit comparator will compare the 2-bit binary x1 x0 with y1 y0. The x greater output is at logic 1 when the value of x greater than y. Meanwhile, the equal output is at logic 1 when x is exactly equal to y. So I make the K-map and Boolean. I made the K-map based on the truth table. So I also made the Boolean expression based on the K-map. So this is block diagram for 2-bit comparator. Consists 4 NOT gate, 4 AND gate, 1 OR gate, and 2 XNOR. After that, we need to create the truth table based on theory that we get from the node. So this is question 6. Based on question 6, design a decoder that accepts 3-bit input and display alphabet at the 7th segment as illustrated at figure 4. The input-output mapping is shown in table 2. Based on question 6, I have to create the truth table, K-map, and circuit. For the first input, 0, 0, 0, I set the numbering to A. I use output A, B, C, D, E, F, and G to make the output A. Then we go through the K-map. For K-map, we need to do for each output. So I have 7 K-map consists each output. For each K-map, we have to make the Boolean expression. So the K-map I make is based on the truth table. This is the circuit connection that using 3-bit input. This is the last question for this assignment. Based on the question given, I have to draw output waveform in proper relation to inputs. From the question given, I have 4-to-1 multiplexer circuit. The circuit consists 4 data input, 2 selector, and 1 output. This is the answer for the question 7. So I compile the 4-to-1 multiplexer circuit using quarters to get the output waveform. Then I made the truth table based on the output waveform. So that's all from me. Thank you. I'm sorry for my bad in explaining the answer that I done. Thank you and Assalamualaikum warahmatullahi wabarakatuh.